Hello, ladies and gentlemen. Today we're going to take a look at surface area and volume of spheres. So it's time for that last section in your foldable. We're going to write down about both surface area and volume today. The first thing you should remember or know is that just like a circle, a radius can be found on a sphere as well, except it comes from the inside, kind of like where the core of the Earth would be, and out to the outer edge of the sphere. So this would be what the radius looks like. I know it looks a lot like the radius of a circle, but remember we're talking about a 3D object when we look at spheres, okay? So you should also remember from your earlier mathematics education here, if you cut a sphere right down the middle, you would create two halves called hemispheres. And it's just like what you learned when you learned about the globe, right? We have the northern and the southern hemisphere, same idea. So if we cut that sphere in half, we would have two hemispheres. And if you look at the cross-section form, so if you cut it in half and then look down at it at bird's eye view, you would have a circle. It's called a great circle of the sphere, that idea that it's the great circle around, okay? So let's first of all get our formula into our foldable here where we have the surface area equals 4 pi r squared. This is the surface area formula for a sphere. Notice all you need is a radius, okay? Just an r. So let's look at one example of this. You may want to copy this one into your notes. We have the surface area of a sphere here. We're going to try to find it. We have the radius is 8, okay? So according to our knowledge, the surface area equals 4 pi r squared. That's the formula. And if we take that 8 and we plug it in there where the r is, it would look like this. Surface area equals 4 pi 8 squared. And then if we actually calculated that in our calculator, we would come up with a surface area of being about 804.25 square inches. Remember, when we're talking about area, that's always labeled in square inches or square feet, square units, okay? So there are other different ways that we can work with our information to find surface area. For example, what if you only knew the circumference of a great circle around a sphere is 25 inches? So this time you don't know a radius, you know the distance all the way around the sphere, so that circumference, okay? You know this measurement right here, that circumference. We need to find the surface area. Well, we don't know a radius, but we can use our circumference formula from last units here to find that radius. So circumference equals 2 pi r, and if we plug in the circumference we know is 25. Now see what we're about to do? To try to find that r, we can just divide by 2 and pi, and that would leave the r by himself, and we would find out that the radius is 3.979. So if I know the radius, then I just use that surface area formula. But on this one, I didn't know the radius, so I had to use what I was given to find it. So now if I plug it into the surface area formula, 4 pi r squared, you can see I plugged in the 3.979 for the r, we can come up with a surface area of 198.96 square inches. All right, and we can also use surface area that's given to us to find the radius. Notice this time the surface area is 804.25. We need to find out what the radius is. We can use our surface area formula, plug in the surface area that we know, and then you can see what's about to happen here. If I was going to try to solve for the r, I would need to divide by the 4 and the pi to make them cancel out, okay? Divide by 4 in my calculator, divide by pi in my calculator, and I'd get 64 equals r squared. Now to undo the squared, remember, how do we undo a squared? We do the inverse, which is square root. So you come up with a radius of 8, okay? Radius of 8. All right, so next formula we need to write in our foldable is volume. So volume is the amount of space inside the object, okay? So rather than the surface area around the outside, we want to know how much water it can hold. So the volume formula equals 4 pi r cubed over 3. Sometimes this is written as 4/3 pi r cubed. Both of them are the same thing, okay? Both of them are the same deal. So this is the volume. We want to find the volume of a sphere. Maybe an example we would write down. Volume equals 4 pi r cubed divided by 3. So we plug in the radius that we're given. Now 2 to the third power means 2 times 2 times 2. Okay, 2 times 2 times 2. That's what 2 to the third power is. It's not 6, it's 8. And if we ask our calculator what that whole calculation is, it comes up with 33.51 centimeters cubed because, again, we're talking about volume this time. So what if I had the volume and needed to find the radius? What if I knew the volume of this sphere was 33.51 centimeters cubed and I needed to find the radius? Well, I'd just take that number here, right? This is the volume, and I'd stick it right there and do some algebra to get my r alone. So 33.51 equals 4 pi r cubed divided by 3. Now to undo my steps here to get the r alone, maybe I would multiply by 3 to get rid of the dividing by 3. So my next step here is 100.53 equals 4 pi r cubed. Divide by 4 pi, and you get 8 equals r cubed. That was me dividing by 4 pi. And now the tricky part, this is what number to the third power makes 8. So what number times itself 3 times would give you 8? If you aren't sure, you can ask your calculator by doing the cube root button on your calculator. Instead of a square root, you have to do the cube root, or you can calculate it, trial and error, I guess. 1 times 1 times 1 doesn't make 8. 2 times 2 times 2 does make 8. And because that is the fact, then we would say the r is 2. Okay? So that's our basic understanding of surface area and volume of spheres. So you should have those two formulas and a couple examples in your notes, and I want to thank you for taking good notes.